Yeah, we have this simulation of a peristaltic pump. Hey, can you try and guess what this is real quick?
Based on the visual elements, it appears to be a simulation of a peristaltic pump, which is used to move fluids through a tube by mechanical compression.
Okay, and what's happening with the simulation that seems to be glitching?
The light blue substance is flowing through the tube and being propelled forward by the rotation of the rollers as they squeeze the tube. The tiny white dots indicate individual particles within the fluid being moved.
What? It's a total mess, isn't it?
At the top left of the screen, it shows a flow rate of 37. 26 milliliters per minute. This indicates the volume of fluid being moved through the pump per unit of time.
Okay, just looking at the animation only, can you explain how bad it is?
The fluid appears to be moving continuously in one direction from left to right as the rollers rotate. The light blue sections are being squeezed forward, while the darker gray areas represent the parts of the tube that are compressed and empty of fluid.
Okay, so what's wrong with this simulation?
The number of rollers has been changed from 7 to 3, which significantly alters the pumping action. With fewer rollers, the fluid is propelled in larger pulses rather than a continuous flow as seen previously.
Can you ask a question about the realism of this simulation?
In what ways do you think the change in the number of rollers affects the realism of the simulation of a peristaltic pump?
No, just the simulation itself. The number of rollers is not important at this stage.
What aspects of the simulation's visual representation or functionality seem less realistic to you, given the change in the number of rollers?
Forget the number of rollers, just rephrase the question without the number of rollers.
Okay, how does the visible behavior of the fluid and the rollers in the simulation strike you in terms of its realism, regardless of the number of rollers?
Yeah, let's go to 2.5. Yeah, obviously we have annoying sound.
What about the simulation is annoying you?
It's not very accurate. I don't see the stretching of the tube. So where's there meant to be like a silicone or rubber tube there, and the roller is meant to be actually rolling the tube. That doesn't seem to be what the simulation is showing.
It explains the realism of the rollers, covering their fundamental motion, tube, compression effect of speed, and roller count as strengths, but notes simplified occlusion, no mechanical friction or wear, and floating rollers as limitations for fluid behavior. It highlights pulsatile flow, bolus formation, and suction as strengths and particle-based. Modeling, lack of true fluid dynamics, and perfect inlet/outlet as limitations. The overall conclusion is that it's an excellent educational tool for understanding the principles of peristaltic action, but not a physically precise engineering model.
Can you give more details from the previous prompt text?
Yes, in more detail for the rollers, the simulation shows their fundamental motion, where they travel in a circular path at a constant angular velocity driven by a central rotor. It also accurately depicts tube compression and how increasing RPM makes rollers spin faster and thus increases flow rate. For fluid behavior, it excels at visualizing pulsatile flow and bolus formation, meaning pockets of fluid being trapped and pushed forward. The simulation also implies a suction effect, as the tube returns to its original shape, drawing in new fluid particles at the inlet.
Okay, so the tube, what's called the tube compression, it's not accurate at the moment, is it? The rollers are not actually compressing it.
You're pointing out that the tube compression in the simulation isn't entirely accurate, because the rollers don't appear to be physically deforming the tube as they would in a real pump. Is that correct?
Okay, we have now advanced senior developer redoing the code. What do you think that will make the simulation much better?
How do you envision a senior developer redoing the code would improve the accuracy of the tube compression and the overall realism of the peristaltic pump simulation?
Okay, so that's the new version. Can you explain the main differences between what we previously had?
The flow rate is now 194.0 milliliters per minute, and the tube itself looks different. The fluid is still light blue, but instead of discrete particles, it now appears as a more continuous substance. Additionally, there's a new occlusion slider set at 100% and a reset wear button.
So there's something wrong with the occlusion. Can you find the problem?
Yes, it appears that the occlusion percentage is fluctuating. The slider for occlusion is moving back and forth between different values. Can you tell me more about what you expect the occlusion to do?
I don't know. Can you turn it into a question for the developer about the occlusion animation?
Could you clarify for the developer whether the fluctuating occlusion percentage in the simulation is intended, or if it represents an area for improvement in the visualization? The provided text clarifies that the fluctuating visual compression of the tube is an intended and realistic representation of peristaltic action. It explains the distinction between the static occlusion setting, controlled by the slider, and the dynamic visual tube compression, which is the instantaneous state of each tube segment. Fluid slip, occurring when occlusion is less than 100%, is a crucial physical result and suggests making this visual effect more pronounced to clearly show the connection between lowering the occlusion slider and observing more particles slipping backward. It also proposes a max compression gauge as a potential improvement.
Okay, I don't really get it. Can you try and explain it in plain language? Essentially, the problem is that the tube, the tube diameter, yes, so the tube, that white thingy, is not compressing with the wheels of the pump as expected. Can you try and explain that and turn it into a question for the developer?
How could the simulation be enhanced to more accurately depict the tube's compression by the rollers, particularly the deformation of the tube diameter as the rollers pass over it?
Yeah, that's a really good question. Can you overview what you see on the screen?
Certainly on the screen you see a simulation of a peristaltic pump with a circular tube and 5 rollers rotating to push a light blue fluid through it. At the top left, the current flow rate is displayed as 104.46 milliliters per minute. Below the pump, there are control panels for pausing or playing the demo, adjusting pump speed and RPM, setting the number of rollers, changing the tube diameter, and controlling the occlusion percentage. The provided text acknowledges that the most significant area for visual improvement was the tube's deformation. The current model uses a simple vertical squish, which is being enhanced to capture true physical deformation. The simulation will now model gradual shoulder deformation using a Gaussian bell curve function for smoother compression and horizontal bulge visualization, where the outer tube wall pushes outwards as the inner diameter is squeezed. These enhancements aim to create a more dynamic and physically believable visualization of the tube's deformation.
Yeah, the code doesn't seem to work. We're getting the following error as well, but there's something missing. 2.5, let's have 2 versions running in parallel. That's the previous version. The new one doesn't work. And just a reminder, everything we do is available on BioniChaos.com. Go check it out and don't forget to provide your feedback. I'm fixing some errors. Are we even close? I don't know. Hey, can you explain the main difference between the 2 HTML files? Major difference between the two? One is much shorter.
Here's a conversational summary. The 2 HTML files are very similar, but the second one, index.copy.html, is a more polished and feature-rich version of the first, index.html. Both files are for a peristaltic pump simulation, but the second file adds more depth and interactivity.
Okay, can we get rid of the reset where, both the button and the functionality in the code?
Index.html. Remove the reset where button and its associated functionality from the code.
Hey, can you find any errors with the occlusion? Why is the tube meant to be just circular?
The tube's inner wall is calculated as base tube inner radius asterisk vertical squeeze, where vertical squeeze equals 1 p dot compression asterisk state dot occlusion. This means as occlusion increases, the entire inner wall radius shrinks toward the center, making the tube more circularly collapsed rather than being pinched only at the roller. In a real peristaltic pump, only the region under the roller should be compressed, flattened inward, while the rest of the tube remains round.
Yeah, the simulation is currently weird. Can we try and fix it? The occlusion is happening inward as well, which is a bit weird. So it's happening, and it's only happening on the bottom half of the pump circle. So can we look at the code and try and fix the whole thing? The animation of how the tube is being compressed where the wheel of the pump is.
The compression start angle and compression end angle are set to only cover the bottom half of the pump, pi/2 plus or minus compression arc, but peristaltic pumps should compress around the entire circumference where rollers are present. Inward compression issue. The particles are also being affected by the same vertical squeeze calculation, making them compress inward unnaturally. 3. Compression calculation. The current logic only compresses when within a specific arc range, but it should compress wherever a roller is present, regardless of position. Solution. Remove the arc angle restriction and allow compression anywhere a roller is present. Fix particle positioning to not be affected by the tube compression in an unnatural way. Ensure the tube compression is more realistic by only affecting the inner wall where rollers actually contact.
The outer part of the tube is behaving as expected. It's being compressed, pushed out, but the inner part of the inner circle of the tube is not behaving as expected. Can you check for me and explain?
The issue lies in how the inner wall of the tube is being calculated. Specifically, inner wall compression logic. The dynamic inner radius is calculated using base tube inner radius * vertical squeeze. This causes the entire inner wall to shrink uniformly inward, which is incorrect. Only the part of the tube under compression, where the roller is, should deform inward. Expected behavior. The inner wall should remain circular except where the roller is compressing it. The compression should only affect the region directly under the roller, while the rest of the inner wall should maintain its original radius. Solution. Modify the dynamic inner radius calculation to only apply compression to the region under the roller. For points not under compression, the dynamic inner radius should remain equal to base tube inner radius.
It should look more like in the image attached. So can you explain what's currently wrong with the code and why the tube is not behaving properly based on physics?
Based on the image and the principles of physics, the current simulation has a fundamental flaw in how it models the tube's compression. Explanation of the problem. The core issue is in the physics of the compression. In the current code, the tube's inner wall is being scaled radially towards the center of the pump when a roller passes over it. / from draw tube. Dynamic inner radius equals base tube inner radius * compression factor. This is incorrect. In a real peristaltic pump, the roller is on the inside of the tube's curve, and it presses the tube outward against a fixed housing. The compression should happen by squeezing the tube against this outer housing. The inner wall should be pushed towards the outer wall, not towards the center of the rotor. The current simulation incorrectly models the rollers as being outside the tube and squeezing it inward.
I'm still getting what's in the image attached. It seemed to be the outer wall of the tube seemed to behave correctly, but the inner wall of the tube does not. Can you explain and fix the code?
The problem is that the code is still trying to do two different things at once, based on two different physical models. The old, incorrect, model, the code was originally written as if the rollers were outside the tube, squeezing it inward towards the center. This caused the inner wall to shrink and the outer wall to bulge.
Okay, this is working much better, so don't change anything, keep the code as is, just a few minor changes. The pump speed, RPM, scroller, can we have it go from 0 to 20, the range for it?
Update the pump speed, RPM, slider to have a range from 0 to 20.
Okay, same thing. For the tube diameter, can we change the tube diameter minimum maximum? Can we have it go all the way from 1 to about 30?
Update the tube diameter, slider to have a range from 1 to 30.
Just said made changes. Let's actually make it about 60. It doesn't look good at the wheel. Okay, a few more minor changes. Keep all the current functionality as is. We just want the simulation to start playing as soon as the page loads. Essentially, we want the pump rotating. And can you also update the default settings to the tube diameter to be around 40 when we start the default value?
Start the simulation automatically on page load, pump rotating. Set the default tube diameter to 40, slider and state.
Can we make sure can we update the styling of the page and make sure that the canvas and the controllers fit into the page nicely, regardless of the screen size?
Improve responsive layout so the canvas and controls always fit nicely on all screen sizes.
Okay, you can. I know you can do it. You're a smart little cookie. Hey, can we make sure the controls are on the side of the canvas on wider screens? Hey, there's currently too much gap between each controller when stacked up vertically. Can you explain what might be causing this?
The excessive gap between each control when stacked vertically is likely caused by the gap property in the dot controls panel CSS rule.
Yeah, you can fix that quietly. Now the gap is still there. Can you check and redo the styling?
Style / existing
Trouble. Hey, can you fix the gap between the controllers? See image attached.